Evet, yeterli çoğunluk sağlandı mı? Dışarıda hala da zil seslerini duyuyorum ben. Herkese günaydın. Bir kez daha merhaba. ARKİTERA Mimarlık Merkezi tarafından hazırlanan Mimarlar İstanbul'da buluşuyor sloganıyla sizlere seslenen ARKİMEET 2014'ün son günü için hepimiz buradayız. Herkese bir kez daha hoş geldiniz demek istiyorum. Ve ARKİMEET 2014'ün bu son gününde dün aramızda olmayanlar için ufak bir bilgilendirme de yapmak istiyorum. Bu sene yeni bir formatla sizlerin karşısına çıktı ARKİMEET ve bu bilgiyi vermek faydalı. Konuşmacılarımızın sunumları ara verilmeden ard arda devam ediyor ve eş zamanlı olarak kahve ikramımız da gün boyunca sizlere fuaye alanında eşlik edecek.
Günün ilk konuşmasına Institute for Advanced Architecture of Catalonia'da yürütülen Fab City projesinin koordinatörü olan ve aynı zamanda Fab Lab Barcelona'nın da katılımcıları arasında yer alan Tomas Diez'le başlıyoruz. Diez, Smart Citizen, Studio P52 ve Fab 10 Barcelona projelerin kurucu ve yürütücüleri arasında yer alıyor. Kentler, insanlığın en büyük buluşu ve aynı zamanda da en büyük meydan okumasıdır diyor. Diez'i daha akıllı kentler için dağıtılan Zeka başlıklı konuşmasını yapmak üzere sahneye davet ediyoruz.
Hello. I guess it's me because I see my name in the screen because I didn't understand anything. Good morning. I will try to wake you up also. My name is Tomas Diez. I am Venezuelan. I'm an urbanist, but I've been living in Barcelona for the last 8 years. I had the pleasure to help to start the Fab Lab Barcelona 7 years ago. And I've been working mostly with digital fabrication and computer science during this period in Barcelona, which brings me to the intersection between the two things, between urbanism and architecture and technology, and how it affects cities. No? When I studied urbanism, I learned how to look at plans, how to look at maps, how to look to the city from above, and how to understand the different distributions of the programs, the width of streets, the size of plazas and public space. And that's a way in which, mainly the story of urbanism, the recent story of urbanism was built upon. No? Try to understand cities from the very top-down approach and try to build infrastructure for a better living for people on it. That was basically really extremely related with the development of technology. The recent, or the most recent urbanism that we are practicing is based on the latest discoveries in the production of technology. And one important one is the production line that was inserted in the almost 100 years ago, more than 100 years ago, sorry. And that brought us the private car. And basically, the private car helped to build the whole structure around cities. We build cities around streets because we have private cars. And this is something that has been fascinating me. It's not only the recent construction of the cities, but centuries ago, we introduced new technologies that have changed the way we interact between each other, the way we produce technology itself, and the way we construct cities. You can claim that the Renaissance was powered by the invention of a printing press around 500 years ago, and then that boosted the first industrial revolution, which actually started to bring people into the cities and start to create the first urban problems. More recently, as I said before, the production line and the wireless communications, basically the radio and the TV, had built the world as we have it today. And this is mostly, or more or less, the result of that. We have a world in which the production is in the hands of few brands. We have given away the capabilities of production to someone else, and sometimes thousands of miles away from cities itself. You know? And from that Renaissance idea, I mean, the role of a citizen, instead of being a creator, you are a selector of products that are being given to you. So you have just to choose what is better, which is the best option for you to spend the money that you want for investing your time in a job that you don't like. No, this is the world as we build it today. And this is more or less the result. It's just, we end up giving away most of our capabilities, and our brains and our hands are basically now in almost in a standby mode. We are becoming automatas, doing the same things every day, and again, living in this fiction that we are free to choose. The thing is that what is going to happen in the future? We have we know that this is happening today. We are reaching into a not only social crisis, as I said, but also into economical crisis. We are also in a planetary crisis in terms of sustainability or the ecology of a planet based on this model. No? So we are invited to think about the future. And this is something that has been done before. People have imagined the future and how is it going to be. Centuries ago, some of the pictures show that people was imagining that we would be flying by ourselves with little devices. No? But how are we looking at the future today? You know, Google Glass is telling us that we are going to wear strange things and we're going to move our heads in a very weird way in order to have access to digital information. Some other pictures show that drones are going to bring products to our houses, or other drones will be or are shooting porn movies, let's say, from the sky. No? So this is more or less how we're trying to see the wonders of technologies of today and also for the future. Flying things, 3D printers, wearable technologies, but then does it really affect change? Where those technologies come from? Who produced those? No? The thing is that the future might be an idea of the past. As I said before, we are today in a moment in which we don't have time probably to think too much about the future, but actually we need to start to construct the future. And basically, that brings the idea of that the future is now. The future is happening at the moment in every decision that we make and every choice that we make and everything that we make is constructing what is going to be the future. This is related, this immediate or this power of acting in the real time or in the present is powered by two recent inventions in humanity. One is the computers. This is the ENIAC. It's one of the first introduced computers back in the 50s. It was fitting a room of 40 to 50 square meters. And this is the new infrastructure that is helping us to connect in real time with almost everyone. This is how it works, the pipelines of the internet are all over the planet. Then the thing is that our contemporary life is not, it's being powered by these two very advanced or very, let's say, powerful tools, if you allow me to repeat. Internet and computers are giving us, let's say, capabilities that we didn't have before. And it's very recent. I mean, we have been introduced, let's say, tools or ways to socialize between people or to produce content that were not with us. They have been with us only 10 years. If you think about Facebook, in which we communicate with our families, we interact with our friends, it was distributed in 2004. Or YouTube, that actually allow us not only to consume content on demand, but actually to be producers of content in a different way as the TV was. No? Or Twitter, that is allowing people to have a different voice and different opinions around what is happening around them. No? Sometimes we use these tools in a very, let's say, insignificant way or not meaningful way. Sometimes we share what we ate as it was going to change the world. But sometimes it can help to change the world. No? I'm not saying that Twitter is the cause of the Arab Spring, but actually it helps to articulate the interest from many people to affect change, either in their cities or in their countries. No? And basically, we are constructing a new layer of infrastructure. This is more or less the map of internet. I know that it's very difficult to describe it, but basically we are creating a new way of communicating between people in a more distributed way, let's say. Even when there are still challenges, as I showed you before, the map of the pipes of internet in the world, there are some, you know, the infrastructure is still in the power of, is still in the property of a few people. But still, we are starting to communicate without having an intermediators and actually from a peer-to-peer perspective. What is interesting me is that is having seen during these last years the emergence of things like 3D printing and digital fabrication technologies, or how the production means that were before in the hands of the industry are becoming part of, or are becoming accessible for everyone, to people that not necessarily has to be an engineer or has to have a PhD of a master's degree on technology. So on top of the communication, on top of the internet as a tool, and on top of computers as tools that we're using today, we are adding a new dimension to those, which is digital fabrication, which is production of things, which is taking that digital information that we exchange through computers and through the internet and turning it into atoms, into things that you can touch in a matter of minutes, in a matter of few days, using again, digital fabrication technologies like 3D printers, laser cutters, or computer control machines. And as we did with the introduction of tools like, as I said before, like YouTube or Twitter, at the same time and almost in parallel, also tools to act in the physical world through computers had been introduced into our lives. But they haven't been that mainstream as Twitter, let's say. No? This is the Arduino platform, launched in 2005, and that allows you to basically to write computer programs and to build your own interactive projects without having to be an engineer or having to be a computer freak. So you can basically connect this board to your computer as you connect your printer, and you can start to download programs that someone did before and learn how to code, learn how to do computer science without having to be a scientist. No? Or the RepRap project. This is a 3D printer that you can build by buying some parts in the hardware store, and also by 3D printing parts of a 3D printer with other 3D printers. So this is a project that was launched in 2008 in the University of Bath by Dr. Adrian Boyer and Vic Oliver, which basically lowered the access barrier to 3D printing. 3D printing was invented in the 80s. And then if you wanted to buy a 3D printer in the late 90s, you will have to invest $25,000 more or less. But what these guys did is actually reduce the cost of having a 3D printer for below 1,000 euros. And that basically changed the whole market and the whole perspective of 3D printing around the world. So companies like MakerBot and all the boosts of 3D printers or Ultimaker that you see in the entrance of this conference, basically they have to say thank you to these two guys. But then on top of this, it's not only, I know that 3D printing is the thing that will look the most and it looks more shiny and more interesting for everyone. But besides 3D printing, there are other tools that are allowing people to build things. And this is what you can find in Fab Labs, digital fabrication laboratories in where you can make almost anything. As I said before, the first computers were occupying rooms that they were 40 to 50 square meters. A Fab Lab today occupies around 100 square meters, but actually what they are building is the future of manufacturing, the future of how we are going to transform digital information into physical things. So more importantly than that, more important than the technology, you can find people in Fab Labs. People that, they are not machine operators, but they are people that know how to interface between the technology and actually the local needs of the society. This is the Fab Lab in Iceland, and as you can see, you have one 3D printer, but then you have a laser cutter in which you can laser cut different materials, a CNC milling machine in which you can make furniture, machines that you can make, which you can make circuit boards and interactive projects, and other type of equipment that actually helps you not only to construct little plastic things, but actually things that can affect the real world. No? This is the Fab Lab network, more than 435 places like that, equipped with these machines connected through the internet, which are actually building a distributed manufacturing facilities all over the planet. Imagine you design something in Lima, and then you can just send the files to Wellington in New Zealand or to Norway in a matter of seconds. So you don't have to ship things in a container that consumes a lot of oil and also that contaminates the sea, but actually you send just the files and the things are constructed in the other side of the planet and not replicated. More importantly is that people can modify the designs and adapt it to the local needs. No? So this is the Fab Lab network. And what I think is that these are building the means not only to replicate the world as we know it, but actually to innovate and to create new tools that help us to affect change in cities. No? So if you can make almost anything, then, for instance, you can make the things that make almost anything. It means that you can make the machines that make the machines, and so on. So that's some of the challenges that we are facing today with Fab Labs. But actually what I think is a moment, a critical moment in which these tools shouldn't be only a tool for fun or tool for research, but actually they should be tools to affect real change in cities. And I'm going to give you an example later on. So as I told you, the Fab Lab is a fabrication laboratory. We organized the 10th International Fab Lab Conference in Barcelona this summer, and we gathered more than 700 people at the Fab 10 conference that are using these technologies in these more than 400 Fab Labs in the world. And we actually brought more than 5,000 people from Europe and the city of Barcelona to visit the space, to have conferences, to have workshops in which some people from Amsterdam was teaching some people from Israel or some people from Egypt how to build a low-cost prosthesis, for instance, no? Or how the Japanese team was teaching, let's say, fabrication techniques from Japan mixed with digital fabrication to people from all over the world. We also built a huge house, a solar pavilion. Is the third iteration of the Fab Lab houses that we had built before. We run workshops with kids, introduction to new generations to the digital fabrication technologies. Is where the key of the issue is actually you introduce these new technologies into the curriculum on schools. That's an experimentation we are doing. But more importantly, I think that we managed to influence the politicians in Barcelona. In the lower right picture, this guy is the mayor of Barcelona, giving how do you call it? Talking to the press. And basically, what we did is to commit the mayor of Barcelona to press a button in which she was compromising the city to be self-sufficient in the next 40 years. And he pressed the button, and this clock is running now. It's a countdown for the 7th of July of 2054, in which Barcelona should be at least 50% self-sufficient and not depending that much of the things that the city imports into its boundaries. No? And besides that, besides the picture, it's something that we are actually doing. This is the new infrastructure being built in Barcelona. These are both public and private fab labs that some of them are existing in the moment and some of them are going to exist in the coming years, which are going to bring new spaces for people to have access to fabrication equipment as a fab lab. No? So right now we have 2 public fab labs opened by the city of Barcelona and 4 private fab labs. And the idea is to have at least 1 digital fabrication laboratory of this in each district of the city. There are 10 districts. So imagine that it's like in the past, we were building libraries to have access to books. Then we put computers inside libraries. Now we're going to put machines that make things inside libraries that will turn the digital information that have the computers into objects that will solve local needs. No? But this is something that shouldn't come only from the geek movement, let's say. We understand that now is the moment to introduce new players, and this is happening. Big companies are starting to, are playing the game of the maker movement, sometimes in a more like playful way, but the reality is that companies like Airbus or Renault are changing the way they innovate by using fab labs within their organizations. Companies like Coca-Cola or 3D Systems are partnering together to launch initiatives that mix 3D printing with sustainability and, of course, a lot of self-promotion. But we see that there are 3 main components that they should work in an articulated way, which is of course, the industry and the private sector, the public sector as an enabler, and also the civic society as the motor of this. No? So this is what we call the Fab City. The Fab City project, what we are building in Barcelona, that aims to bring back productivity into the city. And instead of importing products that are manufactured thousands of miles away, and then turning them into trash that we don't use, we're trying to introduce new advanced manufacturing facilities that will allow to close the cycle of manufacturing within the city. And then whatever comes in and out is just information about how things are made, but not the things that are being made. So this brings us to the current moment of urbanism. No? This is what we're thinking is going to be the future, but actually I came yesterday from Barcelona that is now living the whole, maybe the biggest event in the world around the smart cities, which is the Smart City Expo. No? So when we talk about smart cities at the moment and this new approach to urbanism through the use of technology, we usually imagine this, no? A super illuminated city with a lot of driverless cars and intelligent stoplights and a lot of sensors. And then basically the thing that is curious for us is last year in the Smart City Expo, the prize for the best smart city in the world was given to this. This is the control operation room of Rio de Janeiro in Brazil. And this is how maybe the corporations and governments imagine what a smart city is. A control center in which all the cities being managed, similar to the rocket launching pad in NASA. And then there is someone like the mayor, the owner of of a corporation controlling whatever is happening there, no? So pressing every button and selecting when the stoplight is on and off, no? So in opposition to that, we have been working in a project inside the Fab Lab Barcelona and also inside the Institute for Advanced Architecture of Catalonia, which is called a Smart Citizen. So in opposition to the smart city as a top-down strategy for developing smarter cities through the use of technologies, what we think is that we need to develop tools for citizen empowerment to be smarter citizens in these cities, no? And that was actually is going to make a city smart is if their people have the knowledge to interact with the city in a new way. So what we try to do is actually to make visible the invisible, things that you are surrounding us, but actually we don't see unless that we have different tools. And then this is basically sensing the city, no? And then including not only by the deployment of sensors by itself, but also including the citizens as part of this process in which people participate by the deployment of sensors in their houses, not to capture private information, but actually information from the streets to report what is going on in the city, to understand what's going on in the city, and then doing it in an open source way for anyone to copy it and to reuse it. This is how we look at the experiment, how we look at maybe 2 or 3 years ago. We were using an Arduino, as I said before, and then we were prototyping some electronic boards in our Fab Lab to look which would be the solutions, no? Well, in that moment, we needed some money to actually fund this research team that we were working, only 6, 7 people working in the project. And for that, to find the funding, we did 2 simultaneous crowdfunding campaigns, or 2 subsequent, sorry, not simultaneous. One was first, and the other one was 9 months after, to raise the funds to support the project. And we managed to get more than 700 people from all over the world that put almost $100 in total, $100,000, sorry, in total, to support the development of the Smart Citizen project. The result is that we could make our first prototypes maybe 2 years ago, 1 year and a half, 2 years ago, and then build what we have today as the Smart Citizen platform. It's an electronic device compatible with Arduino, totally designed and developed by us, with an online platform that allows people to connect and to stream their data and to share it with others. So the sensor kit basically contains small sensors that capture information about the air quality in the city, also data about the temperature, humidity, the amount of light or sound that actually help us to understand the city as microclimates, no? Usually, we understand these values in the city by sensors that are placed very far away from where we walk. Usually, they are placed in the hills of the city, or they are placed next to parks, but actually, they are not placed in the place that I really interact with the city, no? We have more than 800 kits online now, and they have produced more than 260 million data points, each one of them. And they are keeps growing and keeps growing. This is how it looks today. This is it's basically deployed in all over the world, with a special focus in Amsterdam and Manchester and Barcelona. When you do crowd sensing, when you do this kind of, let's say, experiment in which you include people using low-cost sensors, you have some challenges on that, no? And I don't want to say that we have the most wonderful idea, but actually we have also a lot of challenges. We need to develop better tools to have better data quality, which actually compromises the engagement of people of using this data. But also we need to start to think how we as citizens, we relate with data in a new, different way, how these become part of our lives. And that's still a challenge today. Remember I told you about how evil the Smart City approach is and how Rio de Janeiro won last year the Smart City Expo, let's say, award for the best city? Well, in the same year, in 2013, we also won the prize of the innovative idea in the Smart City Expo. So we started to criticize this model 2 years ago, and then 1 year after, we were inside let's say, the belly of a monster, winning an award surrounded by people that were playing a totally different game than us, no? This allows us also to get some traction in another strategy, which is not only away from the grassroots initiatives and only using citizens, but start to collaborate with cities. In this case, we did a deployment of 100 kits smart cities and kits with citizens in Amsterdam, but actually with the support of a Smart City Amsterdam initiative and with the VAC Society, which are our partners and the local champions in Amsterdam. In the same way, we are doing it now at the moment in Manchester with the support of Future Everything, and most importantly, with the support of Intel, which again, we were criticizing, but actually they are now part of this interest on developing new tools for people to participate in whatever means the smart city is, no? And these are some examples. Then to summarize, I just want to say that for me, the most interesting approach of let's say, of the use of these technologies is actually how they can enhance the political life of people in cities. Not only as an act of voting and have some representative practice of a politics, but actually to have an active political life of people in cities through the use of technologies. In this case, through the use of two basic technologies. One is crowd sensing, means that you can actually have tools to capture and stream data to raise important issues in your city today. And then the other one is using digital fabrication tools to propose solutions for problems that you can identify in your city. And I think that with that, I open 6 minutes for questions, if there are some. And thank you very much. Any question? Okay, a question. Okay.
Can you give more examples of the products that come from the smart lab? I understand the chair, it's a physical object, you can get it. Okay. I also understand your sensor. Can you give some examples of other products that are coming out of this Fab Lab?
Yeah, and as I said, there are more than 400 Fab Labs in the world. Some of them are responding to totally different needs. No? For instance, I can give you the example of a Fab 5 project, which is in the Fab Lab in Afghanistan, in Jalalabad, that has produced low-cost internet antennas to provide internet to schools and hospitals. Because basically, Afghanistan, a country under war, you have a lack of infrastructures. So you could build like each antenna will cost less than $20. And then you can have internet being replicated wirelessly in distances more than 5 kilometers. The interesting thing is that project is now being used in Nairobi, in Kenya. It's called Wireless for Africa. And they became a business in Kenya, and they are becoming an internet service provider. There is another project that is the Fab Prosthesis, which is being developed between the Fab Lab of Amsterdam and the Fab Lab in Yogyakarta in Indonesia. And what basically they are doing is building low-cost prostheses for, as you know, in Southeast Asia, there is a lot of old mines that were causing that people lose some legs, let's say. And then to have access to prosthesis, you will have to invest maybe, I don't know, 5,000, 10,000 euros because they are very expensive. So these people were able to reduce the cost of the prosthesis by 10, let's say by a factor of 10. And then actually when you talk about kids, you know, kids grow very fast. So you want to have adaptable prosthesis to grow with them, and that growth shouldn't be that expensive, no? And the same way happens with the hands. The prosthesis for hands that can be 3D printed, and they are around a $50 prosthesis, no? We have built in Barcelona, as I said, this year we built the third iteration of an entire house. The Fab Lab house is a project that the first version we did it in 2010. It is an entire house that you can build in a Fab Lab. And actually, the files are uploaded in our website, and you can download it if you can make it if you want. And then I think that this more critical now is and as I said before, if you can make all these things that contain not only the physical body, but actually the operational part by introducing electronics, you can build the machines. It means that the Fab Lab can build the technology that produces technology. So I think that's the more critical part. Not only, not making a chair or making a house, but actually making things that can affect change in a different way. In this case, the roadmap of the Fab Labs is that within the next 3 to 4 years, we'll be able to reproduce themselves. So if you have a Fab Lab, having more Fab Labs is an issue of having babies inside the lab. No more questions? Okay, so Martin, you're next. Thank you.
Tomas Diez'e konuşması için teşekkür ediyoruz.